Well, happy Monday. So what I wanted to do now is we're going to hit the next sort of stage of the course where we're going to start talking now about really structured ways, uh, you know, to actually program the way that you probably should program. You kind of got the fundamentals down now. If you're wondering, hey Grant, what happened to control flow? The answer is you kind of got everything you need from control flow. You can go ahead and look at that on your own, but we really talked about the if statements. We've talked about loops. We've talked about, I've added concepts of, the switches and things like that. So the point is, we don't need to do a whole chapter on this now. We've got that done. So now we're going to talk about functions. And what I'm going to do is I'm going to sort of, for now, I'm returning to the book a little bit with this example. And of course, you can pause and type that in if you want. I'm going to go with this example, but I am going to return to what I'm calling the fundamental programs that we've been working on so far. The donut one, the financial math one, the mission names one, and the poem analyzer one. But for now, let's look at this because we can get a lot of interesting stuff out of this. And then again, I'm going to return to my friend, the visualizer. So here's the visualizer, and the only thing that's different about the way I've typed this versus the way it was presented in the book, I did not like a bunch of output statements sitting in the middle of the code. So what I more or less did here is I've got my input, I've got my processing, and I've got my output. Otherwise, it's exactly the same. And when we actually run this thing, we'll see that here, at this point, before the program starts, the memory is a blank slate. And then as soon as we start to move forward, boom, in the global frame, out there in the entire memory of Python, we've got ourselves our list. Then we do a little bit of processing here, each time grabbing a piece of memory in our global frame and doing its various processing. And then we basically go ahead and start printing. And then when the program is finished, this stuff is still left up in memory. So what we're going to do now is we're going to make our Python programs, at least in this stage, a little bit more memory efficient, right? Because maybe we don't need to remember this anymore. We have finished running the program. So to do this, I'm going to teach you guys a new statement. And that statement is define. Define. And I'm going to create myself my own function. Now, by the way, these guys here are functions. Sorry, that's not a function, but these guys are len and sum, and we've used them already before. Len is a function that takes in a list and spits out a number, which in this case is the length, how many elements are in that list. Sum is a function. It takes in a list and it returns out the sum of that list. Now, what if I told you you could make your own functions? You could make your own functions. I'm going to make a very boring function at this point. All this function is going to do is it's going to take in a list and it's going to return out a list. You're thinking to yourself, what does that mean? Take in and take out. Or return out. Let me show you. So this guy here, I'm going to call it list processing. And I'm going to say, please, you're going to be able to take in a list. And I'm just going to call it list. Okay. Very similar to ifs and the whiles, you need a colon here to indicate that what's going to follow is part of that structure. If you remember with the ifs, you went if blah blah colon, and then there's a block of code. With the loops, you went while blah blah colon, and there was a block of code. So here again, this is going to be a block of code. And this block of code, all it's going to do at this point is it's going to go print, hello, and then you know what? I can't do this. We got to do this. I'm going to say return. So here's a new guy for you two guys. Return nothing. Return 0. All right. Sorry for the semicolon. That was instinct from my other language. All right. So I'm going to go visualize. Now, what is really interesting here. So here it's going to be passing in a list. It's going to print hello and return nothing. Now, notice right now my little processing dude here, my cursor, I suppose. It's pointing right now at this function. It's getting ready to process it. All it does is it grabs a piece of memory and it's going to call it list processing. And at this point, it's just saying, here's a piece of memory pointing to that function. I never call that function. So it's not going to be a particularly interesting run. It's going to more or less run exactly the same and everything's going to be fine, right? So now let's go ahead and call this function like we called these functions. I'm going to go edit, and sitting out here, I'm going to basically have a variable, which I'm just going to call dummy, which is my way of basically saying that I don't really care what's in it. Dummy is assigned list processing. I'm going to pass it in a list. In this case, I'm going to pass it in data. Line 7. Watch what happens now as we start to run this thing. This thing is going to grab a piece of memory, which is going to be used for list processing. This guy creates something in the global frame for data. Here, line 7 is our interesting line. I'm going to go next and watch what happens for a little arrow here. Now processing, instead of going down, it's going up. And instead of the global frame being highlighted, we've got a whole new section of memory called list processing, the name of our function. And in it, it comes with that list because that's the list I passed in. Now we're going to see it go and it's going to print something. It's going to print hello. It's going to return 0. Here it's basically saying, just so you know, I'm about to spit out 0. 0 is going to be coming out. It's going to come out of here and get dumped into a variable called dummy. And there it is. It's gone, as is our memory that was used for list processing. That's also gone. All right, that's kind of cool. What else can you do with this? Let's do something a little bit more interesting here. What I'm going to do is I am going to get rid of this useless hello statement. And it's called list processing because I kind of envision this processing section not being done out just helter-skelter in the global frame, but in an area that I can control it. I'm going to put it out into my function. So now what this function is going to do, it's going to take in data. It's going to be passed in. It's going to be called list. It's then going to say, okay, what's the length of the list? What's the sum of the list? And then it's going to basically work out what the average is. And then it's going to return 0, which shouldn't make any sense to you at this point, because why would we do all this work and not do anything? But let me, first of all, let's just see how this runs. I'm going to go visualize. I'm going to go. So again, all this does is it defines a little pointer in memory pointing to these sort of steps of the recipe. Then it's going to grab a piece of memory in the global frame called data. Then in this case, we've got dummy, which is just a crappy variable at this point. It's going to go into list processing. Watch what happens when I go next. Bang, processing now goes up to here, list processing. And in here, we've now got a variable called list pointing to that list. It is a really good point as to why data is pointing there and list is pointing there. But for now, can you just ignore that, right? Just imagine inside of list, I've got a list. And so now variable int length, it's not in the global frame anymore. It's defined. It's only going to live inside of list processing. Int sum in list processing. Float average in list processing. Then we're about to leave. We're going to return 0. We're going to return 0 and watch what happens as I leave this function and watch what happens to my friends int length, int sum, and float average. Boom, they're gone. Now, these are just crappy little integers and floats, but imagine that this thing was doing a massive amount of memory and we no longer needed it. What this would do now is as I left my function, all that memory would be freed up. And now, in theory, I'd want to be printing these things. Now, I hope that you're going to see a problem with this. As soon as I go print, it's going to go, and it's going to say, hey, wait a minute, int length is not defined. Well, it's not defined, so it's not here anymore. Int length only lived inside of this function. So to get these things out, we probably should return them. So watch what happens now if instead of going return 0, I say, can you please return the int length, the int sum, if I still needed these, let's just assume I still need them, and the float average. It does seem that both in the book and in this example, we really care about line 2 and 3 to get line 4. But let's imagine that we want to keep these. So I'm going to now run this. Now watch what happens when I visualize the execution. So again, we get our function, get that piece of memory, the list. We're now going to go into list processing. It's going to do its various calculations. Now look at what it's about to return. Instead of 0, it's going to return these 3 things. How do you think Python would want to return a bunch of data as one thing? It would probably want to do it as a composite data type, and it does. It's returning a tuple, right? A tuple, you remember, is a non-modifiable list. So it's returning basically a tuple with those values in it. And so as it comes out, watch what happens to dummy. Dummy becomes that tuple. And all the other stuff that it had to do to process it is now forgotten. It's just now returning out these pieces of memory. And so obviously this is still not going to work, right? Because int length is not defined. But what I could do now is make this thing a little bit better. I could call it list results. Okay, list results. And in this case, say that the list results 0 element is that. The list results first element is that one, and the list results second element, or third element, I should say, is that. So I'm going to go visualize the execution, get rid of my shame, go, 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 run through those, and it's about to return that tuple. It's going to return it into that variable. Bang, up it goes. There's list. And so now it's can we print these things? It's going to print 10. Yes. It's going to print. Yes. It's going to print. Yes. Pretty cool. All right. So now the program is finished. What if I told you I could probably do the whole thing and free up a lot of the memory? Even this, I could probably get it to forget. Well, maybe not forget the data list, because that's going to be my ultimate input. But I'm going to go through and make this thing even better. So to make it even better, I'm going to tell you guys that what typically happens now once you start defining functions is actually, you know what? Well, here's what I could do to make this thing a little bit more, well, yeah, to make this thing a little bit more interesting is I'm going to pass in another, I'm going to repeat this processing here. I'm going to go in here, I'm going to say list results is assigned list processing. And instead of basically just data, I'm going to go 1, 2, 3. I'm going to pass in another list. And then from there, I'm going to say, can you print out the analysis of that list? Then I'm going to go list results is assigned list processing. And let's get another boring list here, 4, 5, 6. And then once I got that done, print that list. So let's visualize that execution for a minute. And just for my own, well, no, we'll enjoy this. All right, up we go, ding, 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 ding. And then we got the various prints things. Now we're going to go in again. So list results, list processing. Watch what happens now. Boom. List processing shows up. It's now pointing to that list. It's going to go through its various stuff. It's going to spit out the return value of apparently 3, whatever, and 2. So then it's going to go down and print those, and it does. Now I'm passing in another list, going back up, and then it prints those guys, and then it's done. Now what I'm hoping you saw there is that I got to repeat this code over and over and over again with different inputs, making it a little bit more efficient, right? Making it more efficient. I could maybe imagine a time that maybe I had multiple lists, and now I'm feeding in each list and doing its processing. Now, what you might be noticing is, Grant, there's a lot of repeat processing still in your program. I mean, sure, you know, I didn't have to repeat these lines. But why am I repeating these lines all the time? And the answer is no real good reason. I should probably put those into a function. So what I can do now is have a list processing. And as these guys are basically output, maybe I could go def list results. Actually, it's just dumb. I'm just going to go print results. Print results. Okay. And what am I going to pass in? Well, I know that this guy's passing out a tuple. So why don't I basically say that this is going to come out as a tuple. Okay, so the tuple. And what we're going to do here is I'm going to take this processing, copy, paste, indent, because remember, that's how it becomes a block of code. And I'm going to go tuple. So print that, and print that. So there's my tuple. And so now I'm going to go list results. I'm going to go and do that. And we're going to test it. So what this guy does is it's going to take this input, it's going to throw it into this function and spit out that tuple, which goes here. They're going to take that tuple, pass it in. It's going to do some printing, and it's not really spitting out anything. And there's actually a name for that, but that's just for now. Make sure this is going to work. Right. So now I got two functions in memory. I'm going to go and it's going to do that processing. It's going to come out. Now it's going to go print results. So it's going to go in with that tuple. It's going to do the print, and it's returning nothing, right? Because there is no return. And out it goes. All right. So in different languages, when you've got a function that's not returning anything, that's called a void function. It's returning the void. It's returning nothing. In Python, as I'm thinking about it now, there is a name for functions that return something, and I cannot think of it. So awesome. I might come back to that in another video and talk about it. I can't think of it now. But anyway, so what you can see there is I've got this, I move this processing up into this function. Well, now I can really kind of simplify my my processing down here now, right? So what I can do is I can say, you know what? That's awesome. Let's copy and dump that there. Dump that there. And because I've kind of standardized everything, it's now, I'm simplifying my program quite a bit. So this thing, we can just assume it's going to run. And it did. I just zoomed right to the end. All right, so that worked. So the only, okay, actually, let me visualize that again and run it to the end. So the only thing I'm going to do now that's going to be slightly even more interesting is that I've got two functions here, but I still am kind of calling programs out, calling these functions out in the global frame. It's better ultimately in your programs if you have one program that you call, which then could call other programs, or one module that can call other modules. It's the convention of Python to call it main, and you'll see that in the book. But what would be better here is if I would go, if I would go and go main and have a main function that does this. I go visualize, and it's mad at me because, of course, I got to go def. It's def main. So here I'm defining. So I'm defining a function called list processing. I'm defining a function called print results, and I'm defining a main function. This is the main entry point. And of course, nothing happens, right? Because I didn't call that function. I didn't call that function. I didn't call the main function. In this script, what I would want to do in the script is I would go and call the main at the end. And so now what we're going to see is that gets defined, that gets defined, that gets defined. And then once we go into main, notice that the data list is now in the main memory, not the global frame. The global frame is pretty light. It's just basically pointing to a bunch of code. But now the main memory fires off. Now now it goes up to list processing. The list processing memory fires off, remembers all that stuff, and it's returning the tuple. List processing disappears. We now go into print results with that tuple. Processing is now going into print results. It's going to do a bunch of print statements. It's not going to return anything because it's a void function. We go out, and then it's going to go list results. Now it's going to grab another piece of memory. It's going to call it list processing. It's gone in with a tuple, does a bunch of crap. It's about to return it. That list process isn't, it's going to disappear. Boom. And now we're going to go and print the results. And so it does a bunch of print statements. Now about to return nothing. Boom. And then it goes off to the next thing. And off we go. And now it's about to print. And it's going to return nothing. The main is about to finish. It's also going to return nothing. And bang. A nice, empty, clean memory. Okay. So I think it's good to stop. What I want you to do, if you really want to get the feel to what's going on, is take this program, which again is based loosely on these slides here, so or this image. So I basically took this program. What I did is they just went ahead and defined one function, but what I ended up doing is I ended up basically defining something that would return not just one value but multiple values. Right, so that's kind of what happened there, and we're going to go one step further in the next slide. But for now, that's what I'd like you to kind of get used to that and run it through the visualizer. It should work without a problem. Just get a feel to what's going on. See if you can predict where that red line is going to go. See if you can predict what's going to happen on your screen. The whole zen of this is super important because we're going to move from this to looking at some of the other programs that we've developed and seeing where we can actually use these ideas. All right, so that's what we got going on for this one.